In this question, we have a capacitor that's initially doing nothing. It's connected in position B, so it's connected across a resistor, and presumably it's completely discharged because it says it's connected for a long time. So that's while it's discharging. So you then have an uncharged capacitor that's then charged because it says the switch has moved to position A. So that means that the capacitor is then connected to the 5-volt source briefly for 1 second. So there you have your capacitor charging for 1 second. And then it's moved back into position B and allowed to discharge through the resistor, again, just for 1 second. So we have a discharged capacitor that's charged for 1 second, and then it's discharged for 1 second. So it's charging for 1 second, it's discharging for 1 second, and they're saying find VC, that is the voltage across the capacitor, at that time. Presumably that means at that 1 second mark. So if we were to sketch what this looks like as a function of time, then you have your capacitor initially increasing. So if this is our voltage across the capacitor, and this is our time in seconds, and this would be in volts, then initially your capacitor would be increasing, it would be charging, but it didn't get a chance to charge to 5 volts. It was interrupted at 1 second. So this here is our 1 second mark. Then the capacitor discharges. So from this point, it discharges. And again, it doesn't get a chance to discharge completely because we only allow it to discharge for 1 second. So again, this is 1 second after 1 second, so that's 2 seconds. So the question is, how much is the voltage across the capacitor at that time? So that's what we're after. We're after this value here. So what's the value of VC? So while it's charging, we know the formula for a charging capacitor. And we're given the values for the resistance, and we're given the value for the capacitor itself. So we can simply write the equation for a charging capacitor. Where is it? So VC equals Vs times 1 minus e to the minus t over R times C. So we can just plug the numbers in and say that's 5 volts because it's a 5-volt supply. 1 minus e to the minus. Now t is going to be 1 second because we're told that it's only put in this position for 1 second. So that's 1 over R is 68 kilo ohms, 68 times 10 to the power 3, and C is 22 microfarad, so 22 times 10 to the minus 6. If you put that in your calculator, that will give you 2.44 volt. So we know that the capacitor charges to 2.44 volts. So that's this voltage here. It doesn't get a chance to charge to 5 volts. It only charges to 2.44. So when the capacitor then discharges, we can then use our 2.44 as our initial voltage. So when we look at the discharging cycle, the formula is Vc equals the initial voltage times e to the minus t over Rc. Now in this case, our initial voltage will be the 2.44 volts because it's discharging from 2.44 volts, not from the 5 volts. And the t will be 1 second because it's only discharging for 1 second. It doesn't matter that 2 seconds have passed because it's only been connected. The switch has only been put in position B for 1 second. So now we use the value for R as 48K because now we're looking at the second part of the circuit. So we can say Vc equals 2.44 times e to the minus 1 over 48 kilo ohms times 22 times 10 to the minus 6. And that, if you put in your calculator, will give you 0.95 volt. So that is your final answer.